Thank you for joining me in today's presentation. We continue with our dimension analysis, and this is physics. In my previous video, we have looked at three derived quantity, the dimension of three derived quantity: force, velocity, and acceleration. Very important. For you to understand this dimension analysis in physics, you have to understand the difference between fundamental quantities and the derived quantities. The derived quantities are gotten from the fundamental quantities. Fundamental quantities are time, area, length, temperature, electric current, luminous intensity. All these are fundamental quantities. The derived quantities are velocity, acceleration, force, density, pressure. You can name them. There are many. Okay. So in today's presentation, we want to look at the dimension for density, power, pressure. Let's look at these three derived quantities. And for you to understand this dimension analysis, there are three key things we established. The fact that you must understand those three things in our previous video. Their length, the dimension is L. We have time, which is capital T. Then we have mass, which is capital M. You need to understand these three things. Let's look at example 2 now, because in my previous video, we have looked at example 1. Example 2 now, let's say density. We are asked to find the dimension of density. Let's look at density, for instance. Let's say find the dimension. Find the dimension of what? Of density. Density is a derived quantity, and density is mass over volume. Very important. You have to know all the formulas as far as those fundamental and the derived quantity is concerned. You have to know their formula. Like density is mass over what? Let's write it here. Density is mass divided by volume. Very important. Mass divided by what? Volume. Okay. This mass is nothing but capital M. Okay. Write down the capital M. We are trying to find the dimension now. Divided by volume is L power 3. Volume is what? L power 3. So the dimension now will be M times L power minus 3. Because this is, we have in our denominator, the power is 3. If you take this power to our numerator, it will gain negative. So it will be, that's why we have this minus 3. That's the dimension now for density is M multiplied by L power 3. So write it in square bracket like this. So this will be the dimension for density. Let's look at pressure. Let's move to another example. Let's say pressure now. Looking at dimension, pressure. Pressure is force over what? Force over area. This is the formula for pressure. Very important. You have to know all the formulas for acceleration, force, velocity, and all the derived quantities. You have to know all the formulas for you to analyze their respective dimension. We established the fact in our previous video that force, the dimension for force is M multiplied by L times T power minus 2. This is the dimension for force. You can check my previous video, you will see it. Divided by area is L squared. Area is L squared. Let's analyze this. This L squared that's in the denominator, we can take it to our numerator, it will becomes L power minus 2. Because this power 2 here, if we take it to our numerator, it will gain negative power. Very important. So therefore, the dimension for pressure now, it will be M multiplied by L power 1 times L power minus 2 times T power minus 2. Very important. Because if we take this L squared to our numerator, it will become L power minus 2. So let's simplify this further. This will be M. We have L multiplied by L now. The power, since we have the same base here. We apply multiplication of indices. We pick one of the L and add their power. 1 minus 2, it will be minus 1. Then T power minus 2. So this will now be the dimension for pressure. Very important. So the dimension for pressure is now nothing but M multiplied by L power minus 1 times T power minus 2. And we have to enclose it in this square bracket. Very important. So this is the dimension for pressure.